Download this code from codegive.com, link in the description below. AWS reInvent 2020 Deep Dive, AWS Glue Elastic Views, Tutorial and Code Example. This tutorial provides a deep dive into AWS Glue Elastic Views, a relatively lesser known but powerful feature that simplifies building materialized views from data stored in multiple data stores. We'll explore its core concepts, benefits, how it works under the hood, and walk through a practical example with code. What are AWS Glue Elastic Views? AWS Glue Elastic Views, GLEV, are a serverless, fully managed service that allows you to create materialized views from data residing in different data stores, such as DynamoDB, S3, and Redshift. Instead of writing complex ETL pipelines and managing data synchronization, GLEV automatically transforms and combines data into a single, consistent view, keeping it continuously updated. Key concepts **** source data stores ** the underlying data stores where the data for the materialized view resides. These could be DynamoDB tables, S3 buckets, Parquet or JSON format, Redshift tables, or Aurora MySQL. * target data store * the data store where the materialized view is stored. Currently, only Amazon OpenSearch service, formerly Elasticsearch, is supported as the target. * view definition * the core of GLEV. This is a SQL query, specifically, a simplified version of PartQL, that defines how the data from the source data stores is transformed and combined to create the view. *index * an OpenSearch index that is created and managed by GLEV to store the materialized view. *change data capture, CDC GLEV utilizes CDC mechanisms to efficiently track changes in the source data stores and automatically update the materialized view. For DynamoDB, this uses DynamoDB streams. For S3, it utilizes S3 event notifications. For Redshift and Aurora MySQL, it leverages database activity streams. * materialized view * the resulting, pre-computed view of the data, stored in the OpenSearch index. This allows for low-latency queries against the combined and transformed data. *PartQL * GLEV's view definition language is based on PartQL, a SQL-compatible query language that supports querying data from different sources and formats. Benefits of AWS Glue Elastic Views ***. Simplified data integration ** eliminates the need for complex ETL pipelines and data synchronization logic. Near real-time updates * automatic updates to the materialized view based on changes in the source data stores. Faster query performance * pre-computed views allow for low-latency queries. Ideal for applications that require fast access to aggregated or transformed data. Reduced operational overhead * GLEV is a serverless, fully managed service, reducing the operational burden of managing infrastructure. Improved data consistency * ensures that the materialized view reflects the latest data from the source data stores. Schema evolution support * GLEV can handle schema changes in the source data stores with minimal disruption. Cost-effective * you only pay for the resources used to create and update the materialized views. How AWS Glue Elastic Views works * 1. Define data sources * you specify the source data stores, DynamoDB, S3, Redshift, Aurora MySQL, that will be used to create the materialized view. You'll need the appropriate IAM roles with permissions to access these data sources. 2. Write the view definition, PartQL query. You define the SQL query, PartQL, that specifies how to transform and combine data from the source data stores. This query defines the structure of the materialized view. 3. Create the elastic view *. You use the AWS Glue console, CLI, or SDK to create the elastic view, providing the data sources, view definition, and target OpenSearch domain. 4. Glev creates the infrastructure *. Glev provisions the necessary infrastructure, including an OpenSearch index, CDC mechanisms, and transformation pipelines. 5. Initial data load *. Glev performs an initial load of data from the source data stores into the OpenSearch index. 6. Change data capture, CDC Glev subscribes to changes in the source data stores using their respective CDC mechanisms, dynamodb streams, S3 event notifications, database activity streams. 7. Incremental updates *. When data changes in the source data stores, Glev receives the change events, transforms the data according to the view definition, and updates the OpenSearch index. 8. Querying the view *. You can query the OpenSearch index using the OpenSearch APIs. Practical example, combining customer and order data from DynamoDB. Let's build a materialized view that combines customer data from one DynamoDB table and order data from another DynamoDB table into a single view suitable for fast lookups. Scenario *. Customers table, DynamoDB stores customer information, customer_ID, name, email, address. *. Orders table, DynamoDB stores order information, order_ID, customer_ID, order_date, total_amount. Goal * Create a materialized view in OpenSearch that contains customer information along with their most recent order information. Prerequisites *. AWS account * You need an active AWS account. IAM roles * Create IAM roles with the necessary permissions to access DynamoDB, OpenSearch, and Glue. Specifically, you'll need roles for Elastic View Role * This role allows Glev to access your DynamoDB tables, OpenSearch domain, and Glue resources. Data Source Role, DynamoDB This role allows Glev to read data from your DynamoDB tables and access DynamoDB streams. OpenSearch Domain * You need an OpenSearch domain provisioned and running. Make sure the domain has appropriate access policies configured to allow Glev access. DynamoDB tables * Create the customers and orders DynamoDB tables with the following schema, adjust as needed for your specific use case. Customers table * partition key, customer_ID, string. Attributes, name, string, email, string, address, string. Orders table * partition key, order_ID, string. Attributes, customer_ID, string, order_date, string, ISO 8601 format, total_amount, number. Enable DynamoDB streams * Crucially, you need to enable DynamoDB streams on both the customers and orders tables. Choose the new and old images stream view type. This is required for Glev to capture changes in the tables. AWS CLI * Install and configure the AWS CLI. Step-by-step guide * 1. IAM roles * Elastic View Role, example Elastic View Service Role. Trust Relationship * Data Source Role, example DynamoDB Data Access Role. Trust Relationship * OpenSearch Access Policy * Modify the access policy for your OpenSearch domain to grant Elastic View Service Role the necessary permissions to write to the OpenSearch index. A sample policy might look like this. Important * replace your region, your account ID, your OpenSearch domain, and your glue assets bucket with your actual values. 2. Populate DynamoDB tables, example data. Use the AWS CLI or SDK to insert some sample data into the customers and orders tables. Here's an example using the AWS CLI. 3. Define the view definition, particular. Create a file named view_definition.sql with the following particular query. Explanation asterisk. Asterisk create view customer_order_view as, defines the name of the view that will be created in OpenSearch. Asterisk select. From, selects the desired fields from the source data stores. Asterisk dynamodb. Customers SC, specifies the customer's DynamoDB table as the source, aliased SC. The dynamodb prefix is required. Asterisk dynamodb. Orders as O, specifies the order's DynamoDB table as the source, aliased as O. The dynamodb prefix is required. Asterisk left join. On, performs a left join between the customers and orders tables based on the customer_ID. This ensures that all customers are included in the view, even if they don't have any orders. Asterisk max, o.order_date, as last_order_date, calculates the date of the most recent order for each customer. Asterisk sum, o.total_amount, as total_order_amount, calculates the total order amount for each customer. Asterisk group by, groups the results by customer information to calculate the last_order_date and total_order_amount for each customer. 4. Create the elastic view using the AWS CLI asterisk. Explanation asterisk. Asterisk dash name customer order view, specifies the name of the elastic view. Asterisk dash source configurations, defines the configuration for each source data store. It's a JSON array of source configurations. Asterisk DynamoDB configuration, specifies that the source is a DynamoDB table. Asterisk table name, the name of the DynamoDB table. Asterisk role ARN, the ARN of the IAM role that glev will assume to access the DynamoDB table. Asterisk dash target OpenSearch, specifies that the target data store is OpenSearch. Asterisk dash OpenSearch service configuration, defines the configuration for the OpenSearch domain. Asterisk domain ARN, the ARN of the OpenSearch domain. Asterisk dash service access policy, specifies the IAM role that glev will use to manage the elastic view and access other AWS resources. Asterisk role ARN, the ARN of the elastic view service role. Asterisk dash definition file :view_definition.sql grave accent, specifies the path to the file containing the view definition, particular query. The file // prefix indicates that the definition is read from a file. Asterisk dash index name customer_order_index, specifies the name of the OpenSearch index where the materialized view will be stored. glev will create this index for you. Important asterisk replace your region, your account ID, your OpenSearch domain, and the role ARNs with your actual values. 5. Monitor the elastic view creation asterisk. You can monitor the creation status of the elastic view using the AWS CLI. Look for the status field in the output. It should eventually change from creating to active. Also, check the last update status field for any error messages. 6. Query the OpenSearch index asterisk. Once the elastic view is active, you can query the OpenSearch index using the OpenSearch APIs. You can use curl, the OpenSearch dashboards, or the OpenSearch SDK. Here's an example using curl. Important asterisk. Asterisk replace your OpenSearch domain with the endpoint of your OpenSearch domain. Asterisk replace customer_order_index with the name of the OpenSearch index you specified when creating the elastic view. Asterisk replace your OpenSearch user and your OpenSearch password with your OpenSearch credentials, if your domain is configured with authentication. If your domain is publicly accessible, not recommended, you can omit the U option. The output will be a JSON document containing the results of your query. You should see documents that contain customer information along with their most recent order date and total order amount, as defined in your PartQL query. 7. Test data updates asterisk. Make changes to the data in the customers or orders DynamoDB tables and observe how the materialized view in OpenSearch is automatically updated. For example, add a new order for an existing customer. After a short delay, typically a few seconds to minutes, query the OpenSearch index again. You should see that the last_order_date and total_order_amount for the CUST123 customer have been updated to reflect the new order. Important considerations and troubleshooting asterisk. Asterisk IAM permissions asterisk double check that your IAM roles have the correct permissions. Common errors are missing permissions to access DynamoDB streams, OpenSearch, or S3. Asterisk DynamoDB streams asterisk ensure that DynamoDB streams are enabled on your DynamoDB tables before creating the elastic view. If you enable streams later, the initial data synchronization may not work correctly, and only changes made after enabling streams will be reflected in the view. Asterisk OpenSearch access policy asterisk verify that your OpenSearch domain's access policy allows glev to write to the index. A restrictive policy can prevent glev from creating and updating the materialized view. Asterisk PartQL syntax asterisk pay close attention to the PartQL syntax. glev's PartQL dialect has some limitations compared to standard SQL. Asterisk data types asterisk ensure that the data types in your DynamoDB tables are compatible with the data types in OpenSearch. glev automatically performs some data type conversions, but inconsistencies can lead to errors. Asterisk error logging asterisk check the CloudWatch logs for the elastic view to troubleshoot any errors. glev writes detailed logs that can help you identify the root cause of problems. Asterisk limits asterisk be aware of the limits imposed by AWS Glue elastic views, such as the maximum size of the view definition, the maximum number of source data stores, and the maximum update frequency. Cleaning up asterisk. To avoid incurring unnecessary charges, delete the resources you created in this tutorial. 1. Delete the elastic view asterisk. 2. Delete the OpenSearch index asterisk, optional. If you want to completely remove the data, you can do this via the OpenSearch dashboards or the OpenSearch API. 3. Delete the IAM roles asterisk delete the elastic view service role and DynamoDB data access role IAM roles. 4. Delete the DynamoDB tables asterisk delete the customers and orders DynamoDB tables. 5. Disable DynamoDB streams asterisk disable DynamoDB streams on the DynamoDB tables if you are deleting the tables. Conclusion asterisk. AWS Glue elastic views provide a powerful and convenient way to create materialized views from data stored in different data stores. By simplifying data integration and providing near real-time updates, glev can significantly improve query performance and reduce the operational overhead of managing complex ETL pipelines. This deep dive has shown you how to set up and use glev with DynamoDB and OpenSearch, demonstrating its capabilities and benefits. Remember to carefully plan your data sources, view definitions, and IAM permissions for optimal performance and security. Experiment with other data source types, S3, Redshift, Aurora MySQL, to explore the full potential of AWS Glue Elastic Views.